Hi, welcome back. We're now in 5.3. We're still essentially multiplying polynomials together. The only difference now is we're going to officially introduce foiling and investigate some special products. Okay, so sometimes when you multiply things together, they'll have a particular form to them, and we want to acknowledge those cases. So all right, let's begin with question 1. We want to use the FOIL method, which is basically just the distribution method that I've been teaching you already. It's just we put a name on it. So FOIL means multiply the first, so x times x. Then multiply the outer terms, so that's the O, so it'll be plus x times 4. And then multiply the inner terms, plus 4 times x, and then, so this was the inner, and then multiply the last terms, which is plus 4 times. But if you notice, it's exactly what we did before. You're just basically distributing each term to the second binomial there. So you multiply this times this, and then this times this, and then this times this, and this times this. That's FOIL, but they're going to call it FOIL. Okay, so which I'm sure a lot of you have already heard of that. So, okay. So x times x, anyways, you're adding the exponents. So 1 plus 1 is 2, plus x times 4 is the same as 4 times x. And then 4x, 4 times 4 is 16. And then combine these two inner and outer terms. So you get x squared plus 8x plus 16. And so it's really nothing new. It's just give it a catchy name, I guess. Let's put that up to FOIL. Okay, and then it's just more of the same. Let's try number 5. So we have 5x minus 6 times 4x plus 2. So first 5x times 4x, outer, plus 5x times 2, inner, plus negative 6 times 4x, and then last, plus negative 6 times 2. So we get 5 times 4 is 20, x times x is x squared, plus 5 times 2 is 10x. 6 times 4, and there's a negative there, 24x, and then minus 12, and then combine your like terms. So 20x squared minus 14x minus 12. So 20x squared minus 14x minus 12. More of the same. Oh, this one is a little bit, you gotta be careful. So number 7, we have 1 plus 6x times 1 minus 3x. Okay, so FOIL, first 1 times 1, and of course 1 times 1 is 1, so let's just put 1 there. Then 1 times negative 3x is negative 3x, and then 6x times 1 is 6x. And then 6x times negative 3x is negative 18x squared. Okay. Then we combine our like terms, so we'll have 1 plus 3x, and then minus 18x squared. And if you try to type it in as is, it's not going to work. And the trouble is you not put it in descending order. So you need to have the highest exponent first, and then the next lowest exponent, which would be x to the first, and then the constant term. Okay, so for some problems, you need to use descending order, and it should say in parentheses there whether or not you need it. Usually you always want it in descending order, but sometimes you can get away without it. You don't really need it. So again, number 8, you're going to have the same issue. 7 minus 2y times 1 minus 3y. Okay, so 7 times 1 is 7, and then 7 times negative 3y is negative 21y, And then negative 2y times 1 is negative 2y. And then negative 2y times negative 3y is plus 6y times y is y squared. Okay? So you have 7 minus 21, 22, 23y plus 6y squared. And again, you have the same issue where you need to rewrite it in descending order. Okay. Okay, so this will be 6y squared minus 23y, and then plus 7. Okay. Okay, more of the same. Now we have a little higher powered exponents. This one, the order maybe is not kind of standard. Let's see if we end up with our regular order, or if we have to rearrange it. Okay, I'll multiply it all out. I won't do it in my head. Ultimately, you want to kind of do these in your head, but okay. Plus 5x times negative x, and then plus negative 3 times 6, and then plus negative 3 times negative x. Okay, so that's going to be 30x minus 5x squared minus 18, and then plus 3x. Yeah, so we have to rearrange the order. So I put the negative 5x squared first, and then I'm going to combine the like terms, the 33x, and then finally the minus 18. And that's use descending order. Okay. X squared plus 33x minus 18 would be French for 18. Some higher powered exponents. Let's try this guy. So number 12. We have 6x cubed plus 6 times x squared plus 4. So it's just FOIL first. 6x cubed times x squared. Outer plus 6x cubed times 4 plus inner 6 times x squared plus last 6 times 4. Clean it up. You're adding exponents, x to the 5th plus 24x cubed plus 6x squared plus 24. So this time we have 4 terms, which is okay. There's nothing to combine. Unlike the previous problems, we could usually combine the inner and outer terms, but in this case, no, and that's okay. Okay, so now we're on to special products. This guy, the inner and outer terms will always cancel out for these forms. So the form is a plus b times a minus b, or a minus b times a plus b. And in either case, the deal will be you have a times a, which is a squared. That's the first. And then the outer will be a times negative b, which is negative ab. And then the inner plus a times b. And then the last minus b squared. So the deal is those two middle terms will always cancel, and you'll just be left with the first and the last term squared. Okay, so when the problems get more and more complicated, it's nice to have this form, this idea in your back pocket. But usually in practice, I just go ahead and FOIL, and then I note that the inner and outer terms cancel. I don't really have it kind of memorized as a plus b times a minus b is a squared minus b squared. No, it's kind of just business as usual. And by the way, it's kind of cool in these problems because the inner and outer terms cancel. Okay, so let's take a look at one. I have x times x plus x times 6, and then plus negative 6 times x, and then plus negative 6 times 6. So x times x, you're adding the exponents. 1 plus 1 is 2. Plus x times 6, same as 6 times x. Plus negative 6x is minus 6x. And then negative 6 times positive 6 is minus 36. And lo and behold, there goes the middle terms, and you're just left with the x squared minus 36. Okay. Okay, so more of the same. Let's try this one. We have some r's. So 15, 5, r minus 3 times 5r plus 3. So we know the end answer is going to be 5r squared minus 3 squared. And of course, if you take 5r squared is 5 squared r squared, then minus 9. And that'll be 25r squared minus 9. Okay? But let's go ahead and do it the long way. So first, 5r times 5r outer plus 5r times 3 inner plus negative 3 times 5r, and then last plus negative 3 times 3. So 5r times 5r will be 25r squared plus 3 times 5 is 15r, and then negative 3 times 5 is negative 15r, and then plus negative 3 times 3, let's just write that as minus 9. And of course, the inner and outer terms cancel, and you're left with what we predicted, 25r squared minus 9. I just love using that equal sign instead of a minus. Okay, so another one. This one you can get away with not putting it in descending order. Same for this one. Let's try 17. So we have 1 minus 2r times 1 plus 2r. So the first 1 times 1, the outer 1 times 2r, the inner plus negative 2r times 1, and then the last plus negative 2r times 2r. 1 times 1 is 1, 1 times 2r is 2r, negative 2r times 1 is negative 2r, and then negative 2 times 2 is negative 4, r times r is r squared, goodbye, goodbye, 1 minus 4r squared. So descending order, you need negative 4r squared plus 1, but in this case, it's not really specifying whether you need that, so you can just go 1 minus 4r squared or vice versa. It won't matter. Okay. All right, got some fractions, so we can handle those, no big deal. Let's try the fraction problem. So I have number 18, 3x plus 1/4 times 3x minus 1/4. Okay, so the first, 3x times 3x, the outer plus 3x times negative 1/4, the inner plus 1/4 times 3x, then the last plus 1/4 times negative 1/4. Okay, so 3x times 3x is 9x squared. 3x times negative 1/4, 3 is the same as 3 over 1, so multiplying straight across to get negative 3/4 x, and then plus, same deal here, 3 times 1, 3 over 4x, and then minus, multiplying straight across, 1 all over 16. And again, the inner and outer terms cancel. You have 9x squared minus 1/16. And then we just have some higher degree exponents. Problem 20, y cubed plus 6 times y cubed minus 6. Okay, so first, y cubed times y cubed, outer plus y cubed times negative 6, inner, 6 times y cubed, last plus 6 times negative 6. Adding exponents, get y to the 3 plus 3 is 6. Then minus 6y cubed, and then plus 6y cubed, and then minus 36. Goodbye, goodbye. And you end up with y to the 6 minus 36. Same deal here. With even higher exponents. I guess we could try 22. X to the 12th plus 8 times x to the 12th minus 8. So here, the first x to the 12th times x to the 12th, the outer plus x to the 12th times negative 8, the inner plus 8 times x to the 12th, then the last plus 8 times negative 8. So get x to the 24 minus 8x to the 12th plus 8x to the 12th and minus 64. Boom, boom. X to the 24th minus 64. Okay, so our next special form is when the two binomials are exactly the same. Okay, so let's try not 23, but let's try 24. Okay, so 24, 7x plus 3 to the second power. So when you see that second power, it means to multiply the same thing twice. So you'll write it as 7x plus 3 times 7x plus 3. Now, please note that you cannot kind of distribute that too. So we saw some questions like 7x cubed raised to the third power, and you can kind of think of it as distributing the 3, right? So 7 cubed x to the 9th. This is not the case. This will not work, okay? So you cannot pull one of these jobs and say, well, that's going to be 49x squared plus 3 squared, which is 9. This is definitely wrong, 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 wrong. Okay, this is bad. And you can see that when we multiply it out. So the first 7x times 7x, the outer 7x times 3, the inner 3 times 7x, and then the last 3 times 3. 7 times 7 is 49, x times x is x squared, plus 3 times 7 is 21, x plus 3 times 7 is 21, x plus 9. So the big issue and why you cannot kind of distribute that too is because you'll be missing the inner and outer terms. So if you look at that thing I crossed out, it doesn't have the 21x plus the 21x. Which is, of course, 42x. So you cannot distribute like we did with when we had just some term. If you have a binomial, you're literally going to have to FOIL it out. Okay, so here, 49x squared plus 42x plus 9. Okay, so more of the same. More of the same. Let's try this guy. So 27. So we have 7x squared minus 6 squared. Again, you cannot just distribute that 2 to each term. You have to FOIL. So we expand it. And then it's first. Outer. Inner. And then last. Negative 6 times negative 6 plus 36. Okay, 7 times 7, 49, x to the 4th, add the exponents, minus 42x squared, minus 42x squared, and then plus 36. So we'll have 49x to the 4th minus 84x squared, and then plus 36. Should get the job done. same. Oh, fraction. So let's try 29. 2t plus 3/4 squared. So I have to FOIL. It's 2t plus 3/4 times 2t plus 3/4. Okay, so first 2t times 2t. Outer plus 2t times 3/4. Inner 3/4 times 2t. Last plus 3/4 times 3/4. Okay, 2t times 2t is 4t squared. 2t times 3/4, well, 2 is the same as 2 over 1. Then 2 times 3/4 will be 2 times 3 is 6. All over 4 times 1 is 4. And then plus the same thing. And then plus, multiplying straight across, 9/16. This will be 4t squared plus 6 over 4. So 12/4 t plus 9/16. And then simplify. So we're going to get 4t squared plus 3t plus 9/16. So 4t squared plus 3t plus 9/16. Okay. More fractions, higher exponents, and on to kind of a different problem. So this probably will be have a bunch of cancellations, which is why they're kind of putting it in here. Ultimately, we'll want to kind of do this in reverse order. So you'll be given like this final answer, and then you want to rewrite it like that. So it's kind of like factoring a number into. So you can multiply two numbers together, like 5 times 3, and you get 15. But you can also start with 15 and then factor it into 5 times 3. So right now we're kind of multiplying things out, but later on we'll want to be able to factor it. So you'll want to go in the other direction. In order to do that, you need to kind of have analyzed these special forms, and that will give you a good foot in the door for moving in the opposite direction, because the opposite direction is harder. But anyways, in this case, let's take a look and see what happens. So I'm just going to triply distribute. So I'll have x times x squared. Let's just write that as x cubed. X times 4x will be 4x squared, and then x times 16 will be 16x, and then this one. So negative 4 times x squared is negative 4x squared. Negative 4 times positive 4x is negative 16x. Negative 4 times 16 is negative 64. Okay. Combining like terms, the x cubed is done. There's no other x cubes. 4x squared minus 4x squared is 0. 16x minus 16x is 0. And then minus 64. So these are, these forms will be nice to deal with because it'll be clear how to eventually factor them. In other words, go in the reverse direction. Okay, but for now, you can just use the methods you kind of already learned, and now we're kind of doing a bunch of review problems here. Yeah. So these last set of problems are just review problems. And I don't see anything that's terribly difficult there. Okay, let's do a fraction problem. So it's 41. So get 1/4 z cubed minus 8 times 3/4 z cubed plus 16. So first we'll have 1/4 z cubed times 3/4 z cubed. This, the outer, so that would be 1/4 z cubed times 16 plus the inner will be negative 8 times 3/4 times z cubed. And then the last plus negative 8 times 16. Okay, Multiplying the fractions out in that first term, 1 times 3 over 4 times 4 is 3/16. And then adding the exponents, z to the 6, plus 1/4 times 16. That will be 16 over 4, which is 4, z cubed, minus 8 over 1 times 3 over 4. 4 goes in the 8 2 times. And then you have 2 times 3 over 1 times 1, so that'll be minus 6 z cubed. And then finally, negative 128. Combine like terms, so I'm getting 3/16 z to the 6 minus 2z cubed minus 128. Okay, so 3/16 z to the 6 minus 2z cubed minus, minus 128. Okay, and now some applications. So we're connecting the idea of geometry to algebra. This one is a bit different. It's kind of a donut hole problem. So they're giving you a box within a box, right? So here's the outer box, and its sides are x plus 4, and then x plus 9. And then there's some inner box, and its sides are going to be x plus 2, and then x plus 7. And they want you to find the area of this part without the stuff in the middle. Okay? So it's kind of the donut hole problem. The donut hole problem is if you want to find the area of a donut, what you do is take the area of the outer circle and subtract away the area of the donut hole. Okay? So in our problem, it's a square donut. So to figure out the square donut area, we take the area of the outer donut and subtract away the area of the donut hole. Okay, so in our terms, it'll be the area equals the area of the outer portion, which is just x plus 4, length times width, x plus 4 times x plus 9, minus the area of the inner donut, which is x plus 2 times x plus 7, or the area of the inner, the hole, right? Okay, so I'm going to FOIL out the first guy. So the first guy will be x times x is x squared, x times 9 is 9x, 4 times x is 4x, and then 4 times 9 is 36. And then I gotta be a little careful with this negative, okay? So I'm gonna leave the negative there and put parentheses and put the FOIL results inside the parentheses, because I have to distribute the negative to the entire polynomial. Okay, so first, x times x is x squared, outer, 7 times x, inner, 2 times x, and then last, 2 times 7 is 14. Okay, I'll simplify that a little before I distribute. 9 plus 4 is 13x's, plus 36, and then minus x squared 7 plus 2 is 9x, and then plus 14. Okay. And now I'm going to go ahead and finally distribute. So I have x squared plus 13x plus 36 minus x squared minus 9x minus 14. So I'm just distributing to every term. And then I can combine like terms. So the x squares will cancel. Then I have 13 minus 9 is 4x. And then 36 minus 14, I believe, is 22. Okay. So we turn this geometric problem into an algebra problem, and that is extremely powerful, a very powerful thing to do. Okay, so that about does it for this section. As usual, thank you for watching, and I will see you next time.